Moving on to Chapter 3. These narrated notes cover Section 3.1 on discovering and creating objects. Chapter 3 scope includes all of the following. Our focus will be on discovering and creating objects, Section 3.1. Object-oriented programming even has the word object in it. What are the objects? Objects are items or things. And when we program, we want to consider the entire entity. So for a program with a coin flip, what are the important features? We don't really care what the value of the coin is. All we care about is that it has heads or tails after we flip it. Another example might be a single die. So if I wanted to write a program that included a die, I would want to be sure that I could represent the face value, 1, 2, 3, 4, 5, or 6, and that I could roll it and have it randomly land with one of those faces face up. How does this relate to object-oriented programming? When we're doing object-oriented programming, we want to strip away any of the things that aren't important to the problem at hand. For my coin, I wouldn't care what type of coin it was or what its value was. I would just want to be able to represent the two faces of a coin, heads or tails, and I would want to be able to flip the coin so that it lands heads up or tails up. This is called abstraction, managing the complexity by ignoring details that aren't important. Same thing with our die. We may want to just represent the die as having a face-up side that we can roll. And everything else in terms of a die becomes unimportant then when we program a digital die. Okay, so now that we sort of have the idea about this, how do we make these objects? Well, when we declare objects in Java, we have to describe the class, that's its type. So last semester when you did structured programming, you would have variables of a particular type. This semester when we use objects, we will have objects of a certain class. When we deal with primitives, we describe their type as int or float, etc. When we use classes, we use their class name, for example, coin, and I could name it Lucky, dice, and I could name it 1 die, or class string, I could name my object title. There is a difference between how primitive variables and class objects are stored in memory. And we're going to take a look at that in just a minute. But before we do, keep a few things in mind. All we did so far was to declare objects. That means we specified the class name and we made an identifier name for this particular object of the class. When I do this, we're creating a reference variable that will hold the address of the actual object, which means then that the object itself has to be created separately from the object reference. So here's how we create the actual object. We need to use the new operator and a special purpose method called a constructor. And this is called instantiating an object. Here we see coin Lucky, the equal sign, the operator new, and then the word coin again with parentheses behind it. That second coin with parentheses is a call to the special purpose constructor method that we will write the code for to create the class object. Notice we do the same thing with the dice object 1 die. And we can do the same thing with our string title equals new string James Gosling as an input to the constructor method. Now because strings are so common in Java, Remember, all input and output has to be done as a string object. Java allows us to take some shortcuts with the string class and objects that we're not allowed to take with other types of classes and objects. And the one shortcut it allows us is we don't have to always type the keyword new. And this is a special syntax that only works with the string class, not any other classes. So here we see title assigned Java rocks, inside double quotes, of course. But notice I didn't have to use the keyword new or the class constructor string method. Now I keep talking about methods. Java refers to the actions or the procedures as methods. In C++, we called them functions. They really are the same thing, and you've probably noticed by now they look a lot alike, and they behave an awful lot alike as well. So it's just a difference in terminology. Invoking methods, then, is the same as calling functions. We've seen that once an object has been created or instantiated, we use the dot operator with the name of the method. So we have title.length. Title is the name of the object. Length, with its set of parentheses, is the method. And count is a new variable that we're assigning the result to. Methods, like functions, can return a value, or they can be void methods. A little review. A primitive variable contains the value itself. Objects, when declared, are references that the object reference will hold the address of the actual object. Many people who grew up on C++ would refer to this as a pointer. The difference only being that Java takes care of managing the pointers behind the scenes, so you don't have to. But here's a good picture that shows the difference between these two when stored in memory. Num1 is a primitive and holds value 38. Name1 is an object reference. And so what's contained in its memory cell is the address of the actual string, which contains Steve Jobs. Note the string Steve Jobs is located somewhere else in memory. So the active assignment takes a copy of a value and stores it in a variable. If I have two primitives, num1 and num2, and I make the assignment of num1 to num2, we know that we have now changed the value of num2 to look like num1's value. We have two variables with their own space and memory that both contain the same value. But if I change one, it will not affect the other one's value. It's a little bit different with object references, however. With object references, what is copied is what's contained in memory, the address. And so if name1 reference refers to Steve Jobs in memory, and name2 string object reference refers to Steve Wozniak somewhere in memory, after I do assignment of name1 to name2, now both name1 and name2's contents address will refer to Steve Jobs' memory location. This is an important concept in Java programming. Any questions about it, please post them to the forum. One more concept regarding objects. You'll hear the term alias. An alias is just another name for the same thing. So for instance, when I'm at home, my kids call me Mom. When I'm at Camden County College, my colleagues call me Professor Wright. Other people may call me Miss Wright or Mrs. Wright. So I have a lot of different names, but all of these different references refer to me. We can do this with object references as well. We can have multiple object references that refer to just one object, just like in the previous slide where we assigned name1 and name2 to reference the same string in memory. The difference between a primitive and an object reference is that if I change the object, through one of its aliases, it's changed for all of those aliases because there's only one object that they all refer to. One final note. Behind the scenes, Java takes care of cleaning up leftover objects that aren't being used any longer. Remember, in our Steve Wozniak and Steve Jobs example, we changed name 1 to refer to Steve Jobs. Well, whatever happened then to poor old Wozniak? Well, he's just left out there in memory, and nobody's referring to him anymore. So eventually, Java comes along and does something called garbage collection. It just kind of recaptures the object's memory that's no longer being used. And this is one of the powerful features of Java. In a language like C++, this was the programmer's job to take care of. But Java takes care of that for us automatically.